Hi everyone, I'm going to walk you guys through the Big Ideas 10.3, give you some helpful hints, and some other things that may make it a little bit easier to finish this assignment. So number 1 says describe how to find the experimental probability of an event. So in the video that Mr. Egler just did for today, it will probably look like this, and then have something up here and something down here. So what's on top goes there, what's on the bottom goes there. Go back to the video if you don't remember what those two things were. If you can't find it in the video, it's also on textbook page 414. So either in Mr. Egler's video or on page 414 will help you get that answer. Ooh. Number 3, an event has a theoretical probability of 0.5. What does this mean? So when we're talking about theoretical probabilities, we're talking about how probable it is that you will get something in the perfect world. Theoretically, in theory, what should you get? So if it's 0.5, then there's a 50% chance that you'll get what you want. Exercise 6. Use the bar graph to find the relative frequency of the event. So relative frequency is how often it actually happened. So the relative frequency of spinning a 6, you're going to look at this bar here and look how high the top of this is. It looks like it's halfway between the 6 and the 8, so this one's going to be 7. For number 7, you're going to do the same thing, but we need an even number. So you're going to look at the top of the 2, the 4, and the 6, and add each of those up, and then that would be your total. So make sure you're adding all 3 of those up before you put an answer in. Number 8, use the bar graph to find the experimental probability of the event. So the experimental probability of spinning a number less than 3. Now we're talking about probabilities. We're no longer talking about frequencies, so your answer has to be a fraction. And it looks like in order to figure out what goes on the bottom here, you're going to have to add up all of these. So this one was 8, this is 6, this one is 9, this one's 11, this one is 9, and this one is 7. So we have to add all of those up. All right, so let's see. 8 plus 6 gives us 14. This would be 20. This would be 16. Then we get, this is equal to 20, 30, 40, 50. All right, so our denominator is going to be 50 because they spun it 50 times. And then the numerator is numbers less than 3. So it can't be 3 or bigger. It has to be the addition of these two. So you're going to add 8 plus 6. And whatever you get is what goes on the numerator. Use the bar graph to find an experimental probability. So we're going to do the same thing here. It looks like the same graph. Let's see, 8 and 6 and 9 and 11 and 9 and 7. Yes, it is the same graph. So your denominator is going to be 50. And it's asking to not spin a 1. So we don't need the 1, but we do need to add up all of these, and then that's what goes in your numerator. Use the bar graph to find the experimental probability of the event. We're going to do the same thing. This time we're spinning a 1 or a 3, so you're going to add up this and that's your numerator. Same thing again. Spinning a 7, there are no 7s, so think about what your numerator should be if it's not possible to get a 7. Exercise 12. You check 20 cartons of eggs. 3 of the cartons have at least 1 cracked egg. What is the experimental probability that a carton of eggs has at least 1 cracked egg? So this is going to be a fraction. The total number of cartons goes on the bottom. So see if you can find where it tells you the total number of cartons. And then the numerator is how many cartons have 1 cracked egg. Exercise 15. Use the spinner to find the theoretical probability of an event. Write your answer as a fraction or a percent rounded to the nearest tenth. So now we're going back to theoretical. So that means in theory what should happen, not what happened in real life, but what should happen. So if we're thinking of trying to spin a red, there's 2 possibilities of red out of 6 possibilities total, and then make sure you simplify that. Once you simplify, that's your answer. We're going to do the same thing for exercise 7. We're talking about theoretical probabilities again. Spinning an odd number, think about how many odd numbers there are. That goes there out of a total of 6, and you will need to simplify this one. Exercise 19, we're talking about theoretical probabilities again. Spinning less than 7, how many ways are there to spin less than 7? Out of 6. And that will be what goes here. Exercise 21. Each letter of the alphabet is printed on an index card. So we have like A, B, C, each on a card. What is the theoretical probability of randomly choosing any letter except Z? Write your answer as a fraction or percent rounded to the nearest tenth. So there's 26 possibilities because there's 26 letters in the alphabet. So that's going to go in the denominator. We're talking about theoretical probability. So not you actually do this, but in theory, what should happen in a perfect world. We want to choose any letter but Z. There's one way to choose a Z, and there's 25 ways to choose a letter that's not Z. So this goes here. The bar graph shows the results of spinning the spinner 200 times. Compare the theoretical and experimental probabilities of spinning a 4. So we have a spinner, and then we have someone who actually spun it 200 times, and these were their results. Theoretical probability, we're trying to spin a 4. So in theory, there's one way to spin a 4 out of 5 possibilities. And then looking at the experimental probability, you're going to look here for the numerator and the total for the denominator. Exercise 26. I think we're almost done. Yep, 2 more. So number 26. The bar graph shows the results of spinning a spinner 200 times. Compare the theoretical and experimental probabilities of spinning a 3. So same thing as last time. What's the theoretical? In theory, what should happen if you want to get a 3? How many out of how many possibilities? And then looking here, how many did they actually get over the total of how many they did? And the last one, let me erase my mistake here. We're going to do the same thing here, but we're looking for spinning a number greater than 4. So we're only looking at the 5. Only at the 5 because it's the only number greater than 4.